Right, throw your name on here. It is currently second hour. All right, we are looking at box and whisker plots today. The word and whisker is in parentheses because some people call these box plots, some people call these box and whisker plots. So I want to tell you that both of those are names for this, so that if you hear one or the other, you know that it's the same thing, okay? These are box plots or box and whisker plots. Box plots show us the 5-number summary for a set of data. Full disclosure, the box plots that you are going to make today don't really tell us a ton because the sets of data we're using are really small. Like, I think there's like 9 or 10 numbers in each of them. Because if I were to give you 30 or 40 numbers, your life would be really difficult putting those all in order. It would just be a lot of work. So we're learning how to make these and how to read these. In real life, you would want to use box plots with sets of data where there were a lot more points, but we're not going to make you do that because we can only do so much by hand. So what a box plot shows us is the 5-number summary. The 5 numbers are these 5 numbers here. Minimum and maximum are easy. We put our data in order. Minimum is our lowest. Maximum is our highest. Okay. Then we have also learned how to find our median already. So median is the middle number when your numbers are in order. So middle number. And if your median is in between 2 numbers, you average those out. You guys already learned how to do that back in 7.1 without me. Okay. The 2 new pieces of today are what's called our lower quartile and our upper quartile. So if you take all of your data and split it in half with the median, that's 50% of your data, right? Okay, if you split each of those 50% in half, how much is that? A quarter, or 25%. 25 cents is a quarter, 25% of a dollar is 25 cents is 1 quarter. So a lower quartile is the median of your lower half of your data. So median of our lower half. And then guess what? Your upper quartile is the median of your upper half. So you take all your data, you chop it in half, and then you chop each of those halves into halves. Yes?
How do you chop the middle?
What?
How do you, if there's like an up and
We'll talk about that. Yes. So if it's right in the middle, it's not part of the top or the bottom. But if it isn't right in the middle, you include the lower one and the bottom half of the upper one. We have 2 examples, so we can see the 2 different ways that happens. Good question. Okay. So once we find those 5 numbers, then we are going to just above a number line make our 5-number summary. So how we do that is we make a box that goes from the lower quartile to the median to the upper quartile. So this is the box of a box plot. And then you draw a whisker out to the side that goes to the maximum. And you draw a whisker out to the other side that goes to the minimum. So that's why it's called a box and whisker plot. This is the box from lower quartile to median to upper quartile. And then your whiskers go out to the minimum and out to the maximum. Okay. I feel like there's one more thing I wanted to say. Oh, you guys can also, you might see this in other applications or other like questions or other people giving you assignments. Lower quartile is also called Q1, quartile 1. Upper quartile is sometimes called Q3. Your median is sometimes called Q2 because 2 quarters would be halfway through. I think that's everything for there. Let's talk about ranges. and then we'll do our 2 examples. Okay, so we already did range back in 7.1. Your whole range is your maximum minus your minimum. Interquartile range means between the 2 quartiles. So that would be Q3 minus Q1. Okay. And then the last thing is, in each of the 4 sections of a box plot, so left whisker, left half of the box, right half of the box, right whisker, 25% of your data falls within each section. And for our examples we're going to see today, that's a little iffy just because of where we have to split them. If I were to have hundreds or thousands of pieces of data, it would be way closer to exactly 25%. But with how little data we have today, because again, we don't want to make you do too much work, it's a little wonky, but don't stress out about that. Okay, we've got 2 examples. The reason why we have 2 examples is A, so you can see it twice, and B, because sometimes you have an even number of numbers and sometimes you have an odd number of numbers. So, first example is the speed of pitches in a baseball game in miles per hour. We are going to put these in order to start. Shout if I miss something. We've got 78 and 80. I see 83 and 85. '87 and 91. '93, '95, '97. 93, '95, '97. And then something I always like to do as to catch mistakes early is count 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, then from there, we are going to find our 5-number summary. So minimum and maximum are easy, 78 and 97. 78, 97. And then I'm going to go ahead and do my graph while I find my information. I'm going to put a dot at 78. I'm going to put a dot at 97. Because that's going to be where my whiskers go to. This example happens to take up the whole number line, just because that's the way we made it. Sometimes they won't go all the way to the ends. Okay, then the next thing you need to do is find your median. So this was hard for me to show when I was doing the video for my iPad because I couldn't show you my fingers on my iPad, but now you can see. So I go 1, 2, 3, 4, meet in the middle, 87 is my median. And if your median is right in the middle, put a box or a circle or something around it. So circle, box, mark your median in some way. Okay, so for an example where we have an odd number of numbers, there's going to be one number right in the middle, one median. Since it is exactly in the middle, it's not in the lower half, and it's not going to be in the upper half. We are not going to include it in either. So that means to find our quartile 1, to find our lower quartile, we are only going to look at these 4 numbers. So just look at those 4 numbers and go 1, 2. My lower quartiles are going to be between 80 and 83. So when my medians are between 2 numbers, we add them together, divide by 2. So 80 plus 83, divide by 2. I get 81.5. So that is my quartile 1. Which makes sense. 80 and 83 are 3 apart. Take that 3, split it in half, 1 and a half. So 81.5, 80 plus 1.5 is 81.5. Okay, and then for my upper quartile, I'm only looking at these 4 numbers here. So I go from the outsides, these guys, my upper quartile is between 93 and 95. What is in between 93 and 95? 94. Cool. Any questions on finding any of those numbers? Okay, so then we need to graph them. I said we were going to graph as we go, and then I forgot. So put a vertical line in between 81 and 82 to be 81.5 there. And then we put a line above 87. That's going to be the middle of our box. And a line at 94 is going to be the right side of our box. So I like to put my dot, line, dot, and then connect my box and add my whiskers. So I connect my box. And I always have to fill in a little bit. And then add my whiskers. There we go. Okay, let's do one more example, and then I want to show you some other examples and let you look at them. Since we only have little examples with little amounts of data, I want to show you some real examples with real amounts of data. So flip this over. We are finding the time it takes to travel to work in minutes. It takes me forever to get to work now because I have to go all the way to Grandma and Grandpa's house and then all the way back here, and it's out of the way. So now it takes me like 35 minutes to get here, plus the amount of time it takes to carry a baby inside and say goodbye to it. Okay, used to be like 12 minutes. 8 is the lowest, 10 and 12. 8, 10, 12. 14, 15, 17. Shout if I miss anything, please. 19, 20. And then 22 and 28. I'm that 28 now, or at least. Okay. And then I like to count and double check I have all my data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you cross off and double count, you shouldn't miss anything. Okay. Minimum and maximum are 8 and 28. So 8 and 28. So we go almost to the edges on this one, but again, you don't always go all the way to the outsides. And then median, go from the outsides. 1, 2, 3, 4, 5. I put a vertical line in between 15 and 17. I don't circle either of them because they're not my median. My median is between 15 and 17. So between 15 and 17 is my median, which is 16. Oh, sorry. You can't see the number line down there. My bad. Then to find your median on an example like this, you are going to use the entire bottom half to be your lower half, and you're going to use the entire upper half. So my median of the lower half, I'll go from the outsides, is going to be 12. 12. And my median of the upper half, is going to be 20. 20. Okay. Then we can connect all those into a box. And we can add a whisker to each. Alright, take a second to glue in your notes while I pull up some additional examples I want to show you guys. I don't have like specific additional examples. I figured I would just find one on the internet. Here's a good one. Okay. So I just want to show you guys and like show you a couple where you could be like comparing something. So let's pretend, I don't even know what this is, I just literally found it on Google Images. Let's pretend this is test scores, and let's also pretend there's 100 people in each class, which is not that what high school level, but like at a university that would be realistic. So what this means is that in class A, if there's 100 people in the class, 25 people got between a 70 and a 73, 25 people got between a 73 and a 77, 25 people got between a 77 and an 82, and 25 people got between an 82 and an 85, I think. So that's what that would mean. Whereas this class B, 25 of the 100 people were right here between 72 and 73. So like a quarter of the class got exactly that score. So it shows you how far spread out your data is, which means that at least one person got all the way up to a 93 here, but 25 people got between that 87 and that 93 there. So just looking at box plots, it shows you less of where the specific people are, because maybe of these 25 people, maybe 24 of them got an 88 or an 87 or an 88, but only one of them got a 93. It just shows you how far spread out the data is. Okay, so we are going to work on our assignment. Let me pause the video, because now I'm going to tell you second hour specific things, so I don't need to be recording this. Bye, video, if I can find the button.